Why is spin important in quantum mechanics? Imagine a tiny particle that behaves in ways no classical physics can explain. That's where spin comes into play, a property that changed how we understand the universe. Spin is a fundamental characteristic of particles in quantum mechanics. It acts like an intrinsic form of angular momentum, but it isn't a physical spinning motion like a top. Instead, it's a property built into the particle itself. Its discovery was a major turning point in science because it explained phenomena that classical physics couldn't, like the fine structure of atomic spectra and how electrons behave inside atoms. Scientists first noticed anomalies in atomic emission spectra that didn't fit existing theories. Experiments like the Stern-Gerlach experiment showed particles could be deflected in ways that suggested they had a tiny magnetic property. To explain this, physicists introduced the idea of spin in the mid-1920s. Wolfgang Pauli used spin to develop the exclusion principle, which states that no two electrons in an atom can have the same quantum state if they share the same spin. This rule is key to understanding why atoms have their structure and why the periodic table exists. Spin also helps classify particles into two groups, fermions and bosons. Fermions have half-integer spins like 1/2 or 3/2 and follow Fermi-Dirac statistics. Bosons have whole number spins like 0 or 1 and follow Bose-Einstein statistics. This classification explains how matter stays stable and how forces work at tiny scales. For example, electrons and protons are fermions, while particles like photons are bosons. In 1928, Paul Dirac created an equation that described electrons in a way that included their spin. His work predicted the existence of antimatter, which was later confirmed. Spin's role extends beyond atoms to fields like particle physics, quantum field theory, and quantum information science. It's essential for technologies like magnetic resonance imaging, which uses magnetic properties of particles to create images inside the body. Spintronics is another example, where electron spin is used to develop new types of electronic devices. In quantum computing, spin states serve as qubits, the basic units of quantum information. This makes spin a key player in the future of technology. From the discovery of spin to its application in advanced devices, this property transformed physics and opened new paths for scientific progress. It helped solve long-standing puzzles about atomic structure and led to the development of new theories. Today, spin continues to drive innovations that shape our modern world.